Alright, so you should have read the question to orient yourself as to what I'm about to show you. The first thing we're going to do is start to label our graph. So let's just give this a simple title. We'll say this is the Bay of Fundy. Okay, along the x-axis, let's label that time. Okay, and along the y-axis, this is going to be the depth of the water, so as the tide comes in and out. So I'll just say here, this is the water depth. Okay. Fill this out along with me. So your x-axis is going to be your time. It says in the question that one cycle occurs every 12 hours. So in 12 hours, we're going to have one complete graph of either sine or cos, and that's what we still have to figure out. So I'm just going to change color. Let's use something with green. Along the x-axis, about halfway, I want you to put a dash, and we'll call that 12 hours. It also tells us in the question that at low tide, the depth of the water is 2 meters. So low tide, meaning the least shallow that the water will ever be, is 2 meters. So we're going to show that along the y-axis. Let's put a green line there, and let's put that as 2 meters. Now, we also are told that the tide moves so that the water level goes above and below average by 6 meters. Now that is stated up here. 6 meters below average sea level at low tide and 6 meters above the average sea level at high tide. So here's what we're going to do. Take your pencil and I want you to draw an arrow up to show 6 meters up from 2. So where would that take us along our y-axis? Where is our average sea level really at? Well, 2 plus 6, that's going to bring us to 8. So I'm going to put a dash here. I'm going to show 8 meters. And we also know that at high tide, right, we have to add another 6, right, because 8 meters represents our average. So if we add another 6, this is going to bring us to 14 meters. So in another color, I'm just going to go back to black, I'm going to show you the axis of our sinusoidal function. You can draw a dotted line all the way across your graph. This is that axis. So the second question becomes, what are we drawing? Are we going to draw a sine wave or are we going to draw a cosine wave? Here's how you know. Because the water is going to start at average sea level. How do we know that? It's in the question. Here, I'm underlining it in black. If the water is at average sea level at midnight, let's assume midnight is here. I'm going to show that on the axis. Okay. Then at time 0, or at midnight, our first point is going to be there. We have to complete one cycle in 12 hours. So that means at 12, our point is going to be back at the axis. Well, look at the first point and the last point. They exist on the axis, which means our sinusoidal function will be a sine wave, not a cosine wave. If it was a cosine wave, our starting point would be either at the bottom at 2 or at 14, but we're starting at the axis. So very carefully, I want you to draw yourself a sine wave that starts at 8 and ends at 8 along the axis in 12 hours. So very roughly, again, your sketch is probably going to be larger than mine. We're going to go up, down to the lowest point, and back there. So notice how this works. We reach a high tide at 14, you reach low tide, which is 2 meters, and we have this intermediate point here. We can even label this down here as being 6 hours past midnight. So I can put a 6 here. Okay. And again, this is going to continue for 2 cycles. So let's put 24 hours here, and let's draw another cycle. There we go. Okay. And we know that this midpoint here, this is going to be 18 hours. So I've shown 2 complete cycles of these waves going in and out. So that's our answer for A. Now for B, write an equation to represent the graph. Okay, so here's what we have to work with. The first thing, I'm just going to erase that writing there. First thing we need to do is state that we're actually dealing with a sine function. So beside B, I'm going to write sine of x. What we need to do is to develop an equation, which means I need to figure out what amplitude is, what my k value is, what my d value is, and what my c value is. So let's start at the beginning with A. A is the amplitude, and we know the amplitude. I drew it with the green arrow. The amplitude is 6. So let's put 6 there. K, we know this from the previous lesson. In order to find K, we have to do 360 divided by the period. Well, what's the period of the function? How long does it take for one cycle to be completed? That's 12. So if we do that division, K is 30. D, take your pencil and go to the starting point. I'm going to highlight it in red. Since we start at the y-axis, there has been no phase shift. We haven't moved this graph left or right. We happen to start right at the y-axis. So D is 0. C is the axis. The axis is 8. That was the first thing that we drew. So there's 8. Now that we have this ready, we can state the equation as y equals 6 sine of 30x plus 8. That's your answer for B. Now for C, I'm just going to go to a new slide. For C, it says, asks us to use the equation to estimate the height of the water at 5 p.m. Okay, so here's the problem. Our x-axis is not given in terms of time of the day. It tells us how many hours have passed since midnight. So you're going to ask yourself, at 5 o'clock p.m., how many hours have passed since midnight? Well, that is going to be 17. And so we're going to use 17 as our input. 17 is going to be the x value. So what you're going to do first is rewrite the equation that we've developed from the first part. 6 sine of 30x plus 8. Okay. 17, now again we'll just make a little note here. Number of hours passed since midnight. At 5 p.m. So let's take 17 and plug it in. Take your calculator and you can solve for y. Make sure you multiply 30 times 17 and then take the sign of that number when you're plugging things into your calculator. After you take the sign of 30 times 17, you multiply by 6, and then you add 8. Always follow BEDMAS. Y equals 11 meters. So the depth of the water is 11 meters at 5 p.m. So that concludes example 1. Reread it, make sure your graph is clear, and when you've understood this step, go on to the video for example 2.